All right, so on this first sheet that I have up in front of you, it's basically talking about the three different types of inequalities that you will see in this lesson. All right? First of all, what does the word inequality mean?
Not equal.
Not equal, right? I mean, it could be, it's possible you have a less than or equal to, where it's either less than or it's equal to, but you won't have just the equal sign, something other than plain old equal. So we have simple inequalities on the left, okay? Let me undo that. So simple inequalities over here on this side, simply things like x is greater than negative 3, or x is less than or equal to 4. And I have written an open circle with this one and a closed circle with this one because it has the line. Anytime you have the line, that means you're including the number. So this means x is less than 4, or it can be equal to 4, and that's why I filled in the circle to show you that x is anything in this shaded region, or it's the 4. Now, I also have interval notation underneath here. We're going to go over that in just a second. I think you did that in Algebra 2 last year. But I have another page of just interval notation. All right, so simple inequalities, the most basic simple ones. They're the ones with just one inequality symbol and no absolute value. Okay? One key thing that you have to remember in this course is that whenever you have a negative on your variable with an inequality, what does that do to the inequality? So when you change your sign so that x is positive, that flips the inequality the other way, right? And just to prove that to you, you don't have to write this down, but just to prove it to you, so watch this. If I say 6 is greater than negative 8, everybody agree that 6 is greater than negative 8?
Yeah.
Okay, if I switch the signs and put the 6 negative and the 8 positive, does that symbol still work?
No.
No, negative 6 is less than 8. So anytime you change the signs on both sides, that has to flip the inequality. Okay? So that's what that thing right there is saying to you. Anytime you have a negative on your variable, you must switch the inequality. Okay? These in this column are called compound inequalities. A compound inequality means you have two simple ones. Okay? And those two simple inequalities are tied by either an or an and. The top ones are or, the bottom ones are and. Okay? And we'll go over all those different types. And then the last type of inequality you'll see in this lesson is an absolute value inequality. Okay? And they will be an absolute value less than a positive number, an absolute value greater than a positive number, an absolute value less than a negative number, or an absolute value greater than a positive number. So there's 4 different case scenarios we'll run into there. All right, so every time you do a problem in this lesson, you're going to say, is it a simple inequality, is it a compound inequality, or is it an absolute value? Okay, because you approach them differently. All right, so the compound. Compound means you're taking two inequalities and tying them together with an or an and. And or means to unite the two graphs onto the same graph, the two simple inequalities onto the same graph. And means you take the two simple inequalities and you figure out where they overlap at. So and is overlap, or means unite. Okay? Key things. Memorize that. All right? That will be super helpful to you in the test if you have that memorized. You do not get this sheet on the test. This is all stuff you're expected to know for the ACT and for your test in here. If you're expected to know it on the ACT, I'll expect you to have it memorized for the test. So if you look at these two simple inequalities, I have them graphed. Here's x is less than or equal to negative 3. Here's x is greater than 5. Or means to unite them onto the same graph. So I just shove them onto the same graph. Okay? This one has an or also, but look what these two graphs do. I have the x is greater than or equal to negative 6 right here. X is less than 4 is down here. And so when you unite them onto the same graph, what happens? The whole graph is covered, right? So that means script r, or negative infinity to positive infinity. Okay, because the whole graph is covered. If this was an and problem, I would only be concerned with where they overlap. But since it's a unite, when I unite them, the whole graph is covered and it's script r. Okay, here's an or problem where both arrows shoot the same direction. So here's my top arrow, here's my bottom arrow. When I shoot them onto the same graph or unite them, what is covered? Negative 2 over, right? Anything, any part of the graph that's covered when you unite them becomes part of the answer. Okay? So essentially the answer for this one matches this one. Does that make sense? All right, so if I scroll down here just a little bit and look at those ands. So when you're looking at the ands, you've got this one here, and then this one down here. Those are just graphs of these two, right? And means overlap. So where do the two overlap at? From here to here. So I only show the overlap from negative 6 to 4, including the negative 6, but not the 4. Okay? This and problem down here, they only overlap from here over. And this number 1 does not overlap, so I put an open circle there. Okay, that shows overlap. All right, so that's the key thing we'll be working on today, or these two will probably get to this one tomorrow. So let's go to that other sheet you have that's got the interval notation on it. Let's look at that one. This one right here. Okay, so this is called algebraic notation is what I call it, because if you do mathletes, then this would be algebraic notation. This is called interval notation, and this is simply just a graphical representation. So just to refresh your memory, because this is something people always forget, how do I know when I see a symbol if it's a less than or a greater than? Like, for example, how do I know that's a greater than on the very first blank? Right here. How do I know that's a greater than, not a less than? Right, but how do you know it's a greater than? How do you know not to say less than? Because when you see, the first thing you see on this symbol is the mouth, not the point, right? What direction do you guys read? Left to right. So when you read from the left to the right, on that symbol, what do you see first, the mouth or the point? You see the mouth first, okay? So when you see the mouth first, that's greater than. If you see the point first, it's less than, all right? Now, if x is greater than 5, that means I put an open circle on the 5 to show I'm not including the 5, and everything to the right could be a potential answer for x, right? Okay? And then over here, this is the interval notation that I'm hoping you had exposure to last year. This parentheses means do not include the number. It's basically like an open circle. This is the infinity symbol, and you always put a parentheses around the infinity symbol. You will never have a bracket. Okay, so the next one is exactly the same except for one thing. It's not greater than, it's greater than or equal to. So this time it means I can include the 5 as part of my solution. So close the dot, I'm including the 5, put a bracket to show I'm including the 5. Everybody okay with that? Okay, and then those continue on, less than. So a good rule of thumb, if you have the graph in front of you, start at the left side of the graph, and what do you see? I see the arrow. That means it's going all the way to the left. That means I'm at negative infinity. So I start at negative infinity right here, and I want to get my graph starts at negative infinity, and it goes all the way to 5. So that's why it says negative infinity to 5. Okay? You can never have the negative infinity on the right side. It has to be on the left side of the parentheses bracket thing. Okay? All right, so this one would mean everything between 1 and 5, not including 1 and 5. Everything between 1 and 5, not including. That is not a point. When you're in interval notation, that means everything between 1 and 5. Okay? This means everything between 1 and 5, include the 1. Everything between 1 and 5, include the 5. Everything between 1 and 5, include them both. Does that make sense? And so then down here, let's look at these ones at the bottom. Okay? This says x is less than 1 or x is greater than 5. That means they're going to be united onto the same graph, right? So what do you think this U stands for right here? Unite or union. So to look at this graph here, where does it start? Look at the left side. The solution starts at negative infinity and goes all the way to 1. So that's what this parentheses represents, negative infinity to 1. United with or unioned with 5 to infinity, don't include the 5. So that's what that means. Does that notation make sense? Because you're going to be typing your answers in like all of these over here on this column. You will be typing your answers in interval notation. Okay? So these are all examples of unite. All right. Everybody good with that? Okay, so we're going to try and do some examples. So we'll scroll down there to, you are ready for this page right here. And here's the problem. And see where it says two-step problem? That's the way it's going to be on your screen. It's going to be a two-step problem, all right? So two-step problem, here's what step 1 looks like. Here's what step 2 looks like, okay? I personally, if I were designing the software, would do these the other way around. I would put the number line first and then the interval notation because I think it's easier to get the interval notation from the graph, okay? So you may want to graph it on scratch paper before you do the interval notation, okay? All right, so first thing we want to do is identify, is this a simple inequality, a compound inequality, or an absolute value inequality? Which is that? That's simple. There's only one inequality symbol, right? There's no and, there's no or, there's no absolute value, just one inequality symbol. Now I am going to have to work that out. So you would work it out just like you would if there was an equal sign there. So what would be my first step to working that out? Multiply by 10. Why am I doing that? To get rid of the decimal. All right. So if I multiply that by 10, I'm going to have what? Instead of a 6n, I'm going to have a 60n, right? So I have 60n minus 276 is less than 184 plus 40. Now, if you'd rather work that with the decimals, that's okay too. Okay, so what? You think take 40 n's off of both sides? 40 off of here and 40 off of here will leave me with what? 20n. And now I need to do what? Add 276 to both sides? So if I add 276 to 184, what will I get? 460? Okay, so I have 460 divided by 20. What is 460 divided by 20? Okay, 23. So n is less than 23. So step 1, they want the answer in interval notation. Step 2, they want in the graph. I think it's easier to do the graph first, so I'm going to do the graph first and then go backwards and do the interval. Okay, so if you were doing this for your homework, you'd probably do the graph on paper so that you can get the interval notation. So when you're doing this graph, n is less than 23. I'm going to need, now when you do a graph, these are super nice on the calculator because all you have to do, or on the computer, you just have to find your number. Over here at the end, they will have either parentheses or brackets. And so if you're doing n is less than 23, let's say here's 23. Less than 23 is going to look like this, right? So all you're going to have to do is drag a parentheses over here to the 23 to show, because parentheses mean open circle. So your interval notation is going to be what? Start at the left, negative infinity, going all the way to what? 23. Do I want to include the 23? No. So there's your answer in interval notation. There's your graphical answer. Does that make sense? Okay? That is a simple inequality. Yes, Jada?
How do you know if you include the number?
How do I know what?
The number?
If there is a line underneath here, like if that was a less than or equal to, you would include the number. Okay? And that's all on that inequality sheet that we just went over a second ago. Yep.
Do you always use a parenthesis on the infinity side?
Always use a parentheses on the infinity side, yes. The infinity will never have a bracket. Okay? And you can kind of look at that page that we just went over, this interval one, that one, you know, always refer back to that if you want to know for sure, hey, okay, what constitutes a bracket and not a bracket? Okay? Is everybody ready for example 2? Ask lots of questions on this lesson and pay close attention because this is a hard one. All right, so we're ready for example 2. And how many steps does example 2 have? 4. So we have some problems that are 4-step problems. So we have a 4-step problem. And which type of inequality do I have? Simple, compound, or absolute value? Okay. I have a compound absolute value, and how did you know that it was a compound absolute value? Because there are two inequalities with an or between them. What does the word or mean? Unite. I want to figure out the answers to these two and unite them onto the same graph. Okay, step 1, solve the first inequality. Step 2, solve the second inequality. And then step 3 is give the overall answer in interval notation. And step 4, show it on the graph. Okay? So step 1, I'm supposed to solve the first inequality. So the first inequality is 8x is less than 9x minus 9. So what's that? You're right. There is a less than or equal to, not just a less than. Thank you. All right. Next step would be to do what? Probably subtract 9 from both sides. Okay, so if I subtract a 9 from both sides, I'm going to get a what? Negative x here. These x's will go away on this side. So I'll have negative x is less than or equal to negative 9. Well, it's not my goal to figure out what negative x is equal to. I want to know positive x. So what can I do to get a positive x? Switch the signs. And anytime you switch signs, what does that do to the inequality? Flips it around. So now I have x is greater than or equal to positive 9. X is greater than or equal to positive 9. Notice it says for step 1 to use interval notation. How can I write this using interval notation? And maybe it's helpful to have a graph. So if you need to sketch a graph, just say, hey, here's 9. That would be a closed circle, shade to the right. So if I had to graph that inequality, it would look like that. That may help you write the interval notation. What would I now have an interval notation if I start here at the left and work my way to the right? Why am I drawing a bracket? Because the most left part of this graph has a filled-in circle. That means to include the 9. That's because I have this little line underneath here. So I start at 9, including the 9, and I go all the way to what? Positive infinity. What goes after the infinity? Okay, a parentheses. That is what you're going to type in for step 1 of your first answer. That's step 1. Okay? Step 2, solve the second inequality. So my second inequality is 3 minus 3x is greater than 33. Okay, so how am I going to get x by itself here? Subtract a 3 from both sides. So if I subtract a 3 from both sides, I get 30. Okay, now once again, I don't want x to be negative. I want x to be positive. So you can do this in 1 step or 2 steps. I don't care which. I'll do it in 2 to be thorough for your notes. I'm going to start by just changing the signs and flipping the inequality. Okay, then I'm going to divide by 3. If you want to do it all in 1 step, no problem. But for right now, all I've done is change my signs and flip my inequality. So now if I divide by 3, I get x is less than negative 10. Okay, let me know if anything confuses you or if I'm going too fast. Trying to give you time to write it in your notes. Everybody okay with that? Okay, so you may want a visual picture of that so that you can write the, let's say here's negative 10. If that's negative 10 and I'm less than that, I have an open circle and I'm shading to the left because it says less than. Notice my arrow always matches this thing if x is on the left. How would I write that in interval notation if I start on the left of the graph? Parentheses for negative infinity, and I want to go all the way to what? Negative 10, but don't include the negative 10. There's my answer to step 2. That's what you would type in your calculator. And these parentheses and brackets can be found in the keypad. So you can go to the keypad to find those if you don't want to use the keyboard. Okay? Step 3, give the overall solution. So remember that there was an or between these two, so I want to unite these two onto the same graph. So I have a 9 going that way and a negative 10 going that way. If I unite those onto the same graph, what's going to be covered? Basically those same two things, right? So I'm going to go ahead and do my graph down here. Negative 10 and positive 9. The 9's filled in, and I'm shading to the right. Oh, what happened there with that little... And the 10 is an open circle. The negative 10 shade to the left. So it may be helpful to draw the graph on your paper before you type in step 3, the interval notation. Okay, so now to write my interval notation, I'm basically doing interval notation for this. So on the left-hand side, what do I have? Okay, negative infinity to what? Negative 10, unioned with, bracket, 9 to infinity. Okay, so that's the answer to step 3. That's the answer to step 4. Does that make sense? Okay. We are ready for example 3. Which is another 4-step problem. And this one has an and. Okay, so is it simple, compound, or absolute value? Compound even says that in the instructions, actually, but you should be able to know that because I have 2 inequalities with an and sign, right? Step 1, work out the first one. Step 2, work out the second one. Step 3, interval notation. Step 4 is the graph. Okay, so when you do step 1 on this one, be cautious. What would be the first step you guys would choose to do? I would not distribute. It would. When you distribute, you make the problem bigger, a little more complicated. When you divide by negative 2, you make this problem simpler. But you got to be super careful because if you're changing the signs on both sides, remember that flips the inequality. Okay? So if you're going to divide by a negative in the very beginning of the problem, no problem. Just remember that switches the inequality. Okay? So if I divide this by negative 2, I am going to end up with w minus 1 is greater than or equal to negative 10. Pay close attention to this sign right here. See what happened there? This became positive, that became negative. All right, now all I have to do is add 1 to both sides, right? So if I add a 1 to both sides, w will be greater than or equal to what? To negative 9? Okay, so greater than or equal to negative 9 would look like this. Everybody agree if I had to make a graph of it, that's what it would look like? Okay, so what would my interval notation look like? Bracket, negative 9, all the way to positive infinity. That's my answer for step 1. Does that make sense? Okay, step 2. That one is 10 minus w is less than 11. What would you do first? Okay, subtract 10 from both sides. What do you get? Negative w is less than 1. I need to change my signs. I want w to be positive, not negative, so I'll change signs, which is going to do what to the inequality? Flip it. W is greater than negative 1. So what does that look like? W is greater than negative 1. Let's put negative 1 here. I'm trying to kind of make this in relationship to this one. If negative 9 was over here, negative 9 would be closer to 0. And that's an open circle shade this way. And so now that is going to be what? Start at the left. I have an open circle on negative 1. So that's parentheses negative 1 all the way to infinity. That is my answer for step 2. Is everybody okay with that? Okay. All right. I'm going to go ahead and put those on the same graph. I'm going to put one above and one below, kind of like I did on that one sheet. So let's say that this is negative 9 and this is negative 1. I'm going to put one of those graphs above. Was that one filled in? Yeah, that one should have been filled in. And then this one's below. So what happens when I figure their overlap? Yeah, if I overlap these two, they only overlap from negative 1 on. If this were an or problem instead of an and problem, what would my final graph look like? If I were uniting these together onto the same graph, what would be covered? From -9 over. It would look just like the top graph, right? But when I'm doing a and problem, that means overlap. They overlap from here over, and it looks like the bottom one, okay? So my final graph looks like this because that's where they overlap or unite. Does that make sense? Okay, now I'm going to use that to go back and give my interval notation. So when you do your interval notation, do not put this and this. Just put this final part right here. The only thing I have in my final answer is this, so that is a parentheses, -1 to infinity. Basically looks just like your answer did to step 2. Okay, does that make sense? If this was an or problem, your answer would have, your final interval notation would have looked like this one. Okay? There's no need to write this united with this if it will simplify to something simpler. Okay, does that make sense? Okay, stop me if something does not make sense. Okay, we are ready for example 4. All right, example 4. Notice this is a 2-step problem. What do you think? It says compound. It's telling you, why is this one compound? There's 2 inequalities. Do you think it's an and or an or? This is actually a shortcut way of writing one of the 2. Do you know which one it is? Okay, well, let me give you a hint. So just ignore this because I'm going to erase it in just a second. But if I were to say x is less than 5 and x is greater than 1. On a graph, I would say 1, 5, shade in between. Because it's the overlap of those 2. X is greater than 1 is this one. X is less than 5 is this one, and they overlap here. Right? So whenever you write an and problem, like this one here, I could have shortcutted it by saying this. I could say, hey, x comes in between 1 and 5. Right? X comes in between 1 and 5. Was that on our inequality sheet? Yeah. I believe it was. So if you look at this interval notation sheet, right? Those ones, like that 1, 5 that has the brackets around both, those are shortcuts for ands. Those are all and problems right there. Okay, so you might write that on your sheet, that those right above the ors, those 3 problems above the ors are all, actually the 4 problems above the ors are all ands. Okay? Okay, so that being said, now you know anytime you see 2 inequalities with no word, it's an and problem. Okay? So that being said, we can work this out in the format that it's in. I just need to multiply every term by what to get rid of the fraction? Multiply everything by 8. I'm going to take all 3 of these times 8. So I'm going to write this a little bigger and give us some space to show that we are multiplying by 8. Okay, so it looks exactly like the first problem. I've just added this times 8 in all 3 areas, right? Okay, so what happens to these? They cancel. What am I left with? 16. So I have a 16 left. Okay, what happens, and keep in mind that this 8 is times this whole thing. It's like an 8 over 1, so I can reduce the 8 and the 4. Okay? So 4 goes into 8 how many times? Okay, so 2. Now, if you would like, I'm going to keep that 2 out there because I think we're going to be able to divide everything by 2 in a second. And then on that last term, the 8's disappear and I'm left with an 18. Okay, now can I divide all 3 by 2? Okay, so I'm going to divide everything by 2, divide by 2, divide by 2, divide by 2. And when I get that, or what will I get after I do that? 8 is less than n plus 8 is less than or equal to 9. Okay, what will I need to do now to get rid of this plus 8? What's the opposite of plus 8? Subtract 8. So to all 3 things, I have to subtract 8. Subtract 8, subtract 8, subtract 8. So we're going to subtract 8, subtract 8, subtract 8. And what will I get? 0, less than n, less than or equal to? What is 9 minus 8? Or 9 plus negative 8? 1. Okay, so right there that tells me what n is. N is any number in between what? In between 0 and 1, including the 1, but not including the 0. Okay? So let me shrink that up. Okay, so on my graph, I'm going to say that 0 is right there and 1 is right here, and I want an open circle here and a closed circle here, and I want to shade in between. And those problems always look like that on a graph. The reason they do is because your original 2 graphs would have been this, and it's an and problem, so you're overlapping them, and they overlap from here to here. Yep. Yeah. Okay, so now I need to write that in interval notation. What would that look like in interval notation? Parentheses 0, comma 1, bracket. Does that make sense? Everybody okay with that? All right, that's as far as we're probably going to get for today.